Hello, everybody. Now, the next thing that we're going to learn about, we've only got a little bit of the year left, but logarithms. Now, before I go over these, I just want to mention something. If you have an exponent, the number that gets the exponent, that's called the base. When you are in math, you have something, whether it's a variable or a number that gets an exponent, that is called a base. I mentioned that has to do with what we're going to do today. And it seemed a lot of people had forgotten that. When I did this with a different class already. Now, a logarithm logs are the inverse of exponentials. Just like subtraction is the inverse of addition. They cancel each other out. Multiplication is the inverse of division. Squaring and square rooting are inverses. They're opposites. They undo each other. It's the same idea here. Now, there's two things basically that you do with logarithms. One is just change it between logarithm form and exponential form. And the page that I'm on right now says rewrite each equation in exponential form. The other thing we're going to do with them is use them to solve exponential equations. Now, anyway, like I said, the first thing, just changing the form. This is going to be ridiculously easy. You just got to remember how it works. Normally, like what I had written up there, 3 is the base, 2 is the exponent, 3 squared, 3 times 3, the answer is 9. That's the base, that's the exponent, and that's the answer. Now with a logarithm, there's kind of a way to remember this. It's spelled wrong. Instead of B-A-Y, you use B-A-E for bay. Base, answer, exponent. So all this is saying, change it to exponential form. 17 is the base, the exponent is 2, the answer is 289. That's all I want from this, just understanding how this form works. So base, answer, exponent again. 19 squared, the answer, 361. Number 3, same idea, base, answer, exponent. 6 squared is 36. That one you probably knew without thinking about it there. 6 squared is 36. 4, 169 to the 1/2 power is 13. Now, if you're really thinking, you'll remember how we said 1/2 power means square root. The square root of 169 is 13. But anyway, base, answer, exponent. And that's it. That's all those are. And you're probably used to me saying this. On the regions, those would definitely be a multiple choice. They make it a little bit more complicated, maybe throw in some variables or something, but it's the same idea. Now 6, the next section, same idea, just the other way around. So the base, and this is why I mentioned this earlier, the base is what's getting the exponent. So that's 14. Answer, 196. Exponent 2, base answer exponent. Now, when I had mentioned that these were inverses, like number 6 starts out, a base gets an exponent, and the output is the answer. But when I switch it to logarithm form, it shows this is the inverse. Instead of the exponent giving you the answer, the output is the exponent, that 14 squared there. The log equals 2. It gives you an exponent. So just remember that's how this works. It's the other way around. So the output of a log is an exponent. Base 16 to get 256. And that's what this means. Hey, what power do you raise 16 to get 256? And the answer, 2. You knew that because it says it right above it. And I'll talk a minute about doing these on the calculator if you actually needed to use a calculator for this. 8. Base is what gets the exponent, so 17. What exponent would give you a 1 there? 0. Again, this is just converting from one form to the other. Base answer exponent. Base is 4. The answer up above is 2. The exponent they gave you that is 1/2. And then 10. The base is 6. The output, the exponent was 2. Base answer exponent. When you're converting. Now, like I said, that would be multiple choice. And they don't really ask this kind of next thing I'm going to mention. Just calculating the log. Because you can just type it in. I'll show you how to do that in a minute. But just think about what this would mean right here. I'll show you how to type this in a minute. This would ask you, like if this wasn't a change format one, if this didn't say write as a logarithm, write as an exponential, it just said tell me what that is. Think about it. What that means is base answer exponent. So base 3, 9 would be the answer. What exponent do you raise 3 to get 9? 3 squared is 9. That's what this means. The ones that we just did, you already knew what all the numbers were. It was written down. You were just trying to go back and forth from one form to another, from log form to exponential form. Now I'm gonna share my calculator here. Now you notice that there is a log button on the front. And, well, that looks different. There's no base. The log button on the front uses the base of the number system we use. And if you don't remember what that is, base 10. You got the ones, the tens, the hundreds, the thousands. Each time it goes up by a factor of 10. We use base 10. So it's like there's a little 10 written down there, and that should make sense. What power do you raise 10 to get 100? Well, that's 2. Now, if you had to do any other, if you hit math on A, log base, now you can fill it in. And we're not really going to use this much. I just thought I'd mention it. Um, if for some reason you ever did have to calculate one, like that example I had up there, log base 3, what do you raise 3 to get 9? Well, we know that's 2. Hey, there we go. Uh, the button on the front is log 10, base 10. And if you notice above it, 10 to the x power, hey, that's the inverse. Exponential and logs are inverses. So that's kind of a reminder there with that 10 above the log button that it's base 10. Any other base? You hit math, you go to log base, and it lets you type it in. Let's say we had something crazy like, what do I raise 2 to get 998? Well, who knows? There you go. And that would be something that you would not ever need to know. You have a calculator for it. Now, what we will be doing further with this, and I'm going to share my notebook again here, and I'll have to go back and forth a bit from the notebook to the calculator, but we'll get through it. We're going to use these logarithms to solve these equations. So we have 15 to the v power plus 3.3 equals 56. Now, the way you do these, you got to get them to where all you have is a base and an exponent. You want to cancel out anything not part of the base or exponent first. That's the first step. So like on 11, 15 to the v power plus 3.3. So I'm going to minus 3.3. That is 52.7. Now, you could have never done this before. You don't divide by 15. I know a lot of people probably would try that. That's not what it's saying here. It's not 15 times v. It's 15 to the v power. So what do we raise 15 to get 52.7? Well, who knows? 15 to the first power is 15. 15 squared is 225. So it's somewhere in between 1 and 2, but I mean, there's no reason. No one knows this, just in their brains. The way you do this is you take the log of both sides. When you take the logarithm of both sides, and we're going to just not even write a base down. We'll just use that base 10 button on the front of our calculator. Easiest way to do this. When I was going over the definition of a logarithm, I had said the output of a logarithm is an exponent. And don't forget, there's like a little 10 here. So this part right here, base answer equals an exponent. The output is an exponent. So what I've circled in red there is an exponent. So it's a power raised to the v power. If you remember, when you raise a power to a power, you multiply. You don't have to remember that explanation. What you do have to remember, though, and this is a property of a logarithm, if you take the log of something with an exponent, It just pops it out to the front as multiply. There just pops that v out to the times sign. I'm not going to write that 10 anymore. Anytime you have a logarithm with no base, base 10. We're going to have to write it down. It's like x to the first is just x. You don't write x to the first. You just write x down. Now, the reason that this helps us, I have v times the log of 15. Now I can just divide by that. That I can just type in. I don't even have to use that log base thing on the calculator. I can just use the button on the front. That's why I was doing it with a base 10 logarithm. That's just a plain old logarithm right on the front. So I'll pull up my calculator here for you to see. Now we had log of 52.7 divided by the log of 15. So just type that in, log 52.7. Now you notice that that puts some parentheses on there. So that's one thing you got to remember, close that. Divide log 15. If you don't close that, you might get some weird answers. So 1.46, up at the top it said nearest 10 thousandths. That's 4 decimal places. I don't care about that. We'll just round to the 10th. So all we had to do there was just type that in, log 52.7, close parentheses, divide by log of 15. 1.46, we'll say 1.5. So the answer number 11 is 1.5. Now I'll go back to my notebook. So again, 1.5. B equals 1.5 for that. 12. So like our steps say, we got to cancel anything that is not part of the base and exponent. That 3 is not getting that x power. So I got to divide by 3. 75 divided by 3 is 25. And again, if we want that x to come out to the front, we take the log of both sides. That pops the x out to the front. So x log of 12, log of 25. When you take the logarithm of something with an exponent, it pops it out to the front with a time sign, which helps because now all you got to do is divide by log of 12. And we didn't put any base on these, so they're base 10. So I can just use the log button right on the front of my calculator, which I'm going to do now. Share my calculator again with you. Okay, so log 25, close those parentheses, divide by log 12. 1.29, like I said, we'll go to the 10th, 1.3. 1.3. Same idea. We got to cancel out anything not part of the base and exponent. That 5 times That's not getting that b power, so I'm going to divide. If you type 95 divided by 5 into the calculator, you get 19. And again, if you want to pop that exponent off of that 15, take the log of both sides. That pops that b out front with a times. That helps me because now I can just divide by log of 15. And again, you can probably guess what I'm going to do now. I'm going to switch to my calculator and type that in again. Log of 19 divided by log of 15. Logarithm of 19, close those parentheses, divide by log of 15. 1.08, so 1.1. And I'll switch back to the notebook again. So like I said, that is 1.1 when you round it. And 14. We got to cancel that plus 9 out, so minus 9. $73.6 minus 9, 64.6. Want that x to pop out to the front, take the logarithm again. Take the log of both sides. That pops the x out. Divide by the log of 5. I'm not going to bother to switch this one again. I'll just type that in. Log of 64.6. I will say make sure you close those parentheses. Divide by the log of 5. 2.589, so 2.6. Just a few more things, then that's it. Okay. Now, when we had gone over this formula, I had said we're going to use it again for something new. You deposit $4,000 into an account that earns 2.5% interest yearly. How long will it take to double? Well, $4,000 doubles after the time. That'd be 8,000. That's what I'll fill in for the first day. 4,000 was the starting amount. It'd be the plus, and I gotta pop that over twice, fill in a 0. I'm not just typing just a simple answer here, so I'm gonna actually do 1 plus 0.025, which is just 1.025, the t power. Here it is. don't know the exponent. So we're going to use a logarithm to solve this problem. I got to cancel out anything that's not part of the base and exponent. So this 4,000 multiplying, so I got to cancel it out by dividing. So this is one of the most important things in this class. It's not even that terribly difficult. I hope you're not finding this super difficult. The problem people have is they just don't remember. When you don't know an exponent, to get it to pop out to the front, you take the log. T comes out to the front, and it turns into a product. T times the log of 1.025. Just like on that last page, that just divide. Now, I will share this again just to remind you. So we'll go back to the calculator yet again. Log of 2 divided by log 1.025. Log of 2, make sure you close that parenthesis. Divide by log 1.025. Hit enter. 28.07 says round years 10, so that's 28.1 years. Savings accounts really don't earn you that much money, and yeah, they're not even that high as 2.5%. But anyway, 28.1 years. 28.1 years. And, you know, when we're going over exponential growth and decay, we've talked about it. You've probably heard it on the news and stuff. Uh, Stuff grows exponentially, like viruses or the bacteria questions I mentioned, money, as we just saw, excuse me, on the last question. You know, this sort of thing is what people do with math in reality. And maybe you won't, depending on what you go to college for, but that's the point of learning the basics of it now. It's not just stuff we make up to make your life miserable. I know some of you think that. But anyway, number two, the population of wolves in North Dakota is growing at a rate of 11.2% annually. If there are currently an estimated 3,000, that should say how long will it take to reach 3,900. Sorry for that typo. And again, like I was just saying, you know, this is more what people would do. You use math to make predictions about the future, to be prepared for stuff or to figure problems out, whether it be money or population of wolves, maybe, I don't know. But that's what this sort of thing is used for. So how long will it take to reach 3,900? That's the amount after the time. Currently, so that's the starting amount, 3,000. Pop that decimal over twice. We're talking about it growing. So 1 plus 0.112 is 1.112. We don't know the time. That's why we're going to use math to make a prediction about the future. And again, you gotta cancel out everything besides the base and the exponent. So I'm going to divide by 3,000. You divide 3,900 by 3,000. You get 1.3. And again, just remember, anytime you need to solve for an exponent, unless it's something easy like, 2 to what power gives you 4? Well, you should know that's 2 squared. But, I mean, who in the right mind would know, hey, I know what I raised 1.112 to get 1.3. No one knows that. So you take the log. Anytime you want to pop that decimal or the exponent out, take the log. And it pops it out as multiplication. So again, to cancel out times log of 1.112, you would divide. And I'll just do this on my calculator. Then we're pretty much done. Log of 1.3, close parentheses, divide by log of 1.112, 2.47, so 2.5 years. 2.5, 2.5 years. All right. Now, sorry I couldn't make it to class this morning. So if you have any problems with this later, just email me for some help. The homework assignment I kept very small. There's only 2 word problems, couple equations, and a handful of the switching back and forth from exponential to logarithm using BAE, base answer exponent for logs. Hopefully it shouldn't be too bad though. Have a good one.